Ternary diagram. Ternary diagram is functionally diversified diagram. It is used by the pathologist, social studies, even in soil studies, statistician, economist, physics, chemistry. Basically, it is intensively used by the social scientist as well as the natural scientist. It is related to the three component system, all the attributes normally represented by the percentage value. Ternary diagram, also known as triangular diagram, or its representation used to visualize the data, consists of three components. Basically, it allows to represent the relative proportion or relative percentage of the three components. For ternary diagram, first is step to draw equilateral triangle. It's a equilateral triangle. It's a equilateral triangle. And just identify the middle point. It's the middle point of x-axis. Same way, this is the x-axis and it's the middle point, and it's also the x-axis and it's the middle point. So x, y and z, there are three axes. So identify the middle point and just connect the apex to the opposite sides. Okay, and this is the middle point, this is the apex of opposite side. Similarly, this is the middle point of y-axis and this is the apex, and similarly this is the horizontal line, this is the middle point, and connect just the opposite apex. Okay, this is the first step to draw the any kind of ternary diagram. Okay, next is steps 2 is the just identify the distance. Okay, this is the distance and this is a linear distance and it's also a linear distance. This linear distance, just twice distance of that distance, just twice distance, just twice distance. Okay, this is the total distance from the horizontal base to apex, and if you divided that linear distance, it is segmented into three parts. This is one part, two part and three part. Similarly, this is divided into the three part, first one, second one and third one, and this is the intersecting point. So we can identify that intersecting point as a 0 point. Okay, and second step is that if we identify the 2/3 distance, this is 1/3, this is 1/3 and this is 1/3. So that one is the 2/1/3, that is the 2/3. If we identify the 2/3 distance, this is 2/3 distance, this is 2/3 distance and this is 2/3 distance, and we can easily draw a complete circle to cover the whole triangle, equilateral triangle. This is the step 1. Second step is that third step is that just identify the intersecting point. This is the intersecting point and just take a linear distance, that is 1/3. It's a 1/3 distance, 1/3 distance, 1/3 distance and 1/3 distance. 1/3 distance of whom? That is 1/3 distance of that line, 1/3 distance of that line, 1/3 distance of that line, and this is the line of 50%. This is the 50%. Okay, then we can draw another circle. Okay, you can draw the another circle. Draw properly. My drawing is not so proper, and you can just connect the apex and to that distance. Just connect the midpoint to the another midpoint. This is a midpoint of y-axis. It's a midpoint of z-axis. It's the midpoint of x-axis. Just connect the opposite and and think that this is a small triangle and this contain the linear distance of total axis 1/3 and this axis include the linear distance of 2/3. Okay, I think it's very clear, and go to the second step. It's a trilateral triangle. Here the three axes x, y and z. The basic analogy behind the trilateral circle is that suppose this is x-axis, it's 0 and the value of x-axis is 0 and this is the apex, this is 100. Okay, we can place it that x-axis and y-axis in that triangle. Similarly, suppose it's an y-axis. Suppose this is horizontal axis and suppose it's a horizontal axis and the value of y-axis is 0. That is 0 and the vertical axis of y-axis, that is the vertical axis, suppose the value of the apex is 100. So we can first one, this is the first one, x-axis and y-axis, we can put it in that triangle like that, suppose like that. This is an x-axis and value is 0. Similarly, this is an y-axis and top value is 100. Similarly, second one is the y-axis, that is the horizontal, and value is 0. Value is 0 and the vertical line, that is the apex value, starts from the mid value and it's the 100. This is another axis, this is the 100. And similarly, suppose it's a z-axis, the value of z-axis is 100. This is the z-axis and here the apex, the top of the apex value is 100. Suppose this is the midpoint of z-axis and apex is 100. So this is the basic analogy of the equilateral triangle. The x, y and z axis all are in equal linear distance. Suppose this is the intersecting point. This intersecting point is considered as a 0, as a origin, as a starting point, just like the coordinate system. Okay, and if you measure the linear distance from that point to that point, and suppose this is the x-axis, it's the x-axis, and this point is the midpoint, and y-axis, this point is the midpoint, and it's the z-axis, this point is the midpoint. We just draw a vertical line from starting from the midpoint, just connect the apex, just starting from the midpoint of y-axis, just connect the apex, and similarly just from the midpoint of z-axis connects the apex, then they intersect into the middle. If we take the linear distance, that is linear distance from this point, from this midpoint to the apex point, this midpoint to opposite apex point, this point midpoint to opposite apex point, then we consider the three kind of distance, intersecting distance, this line, and that line, three are equals, and similarly this one, and this one, three are the equal. So if you measure the distance with the help of scale or compass, we can easily get the information that this is the total length. It's the total length. It's the total length. Okay. And this is the 1/3 of the total length. This is the 2/3, another 1/3 of the total length. This is the another 1/3 of the total length. So this distance is the 2/3 distance of the total line, and this was the 1/3 distance. Similarly, this is the total line, and from apex to the intersecting point, that is, this is the 2/3 distance of the total length, and this is the 1/3. And also, and this point to this intersecting point is the 1/3 distance of the total linear distance by length, and intersecting point to apex point, this is the 2/3 distance. So if we take the r radius and we take the linear distance from intersecting point to that one, that 2/3 distance, with the help of compass, and we put the compass in the intersecting point, that is the origin point, this is the middle point or the equilibrium point, and take the linear 2/3 linear distance, and we can easily draw a circle. This is an imaginary circle. Okay, with the help of compass we can perfectly draw the circle, and that this circle includes the whole triangle. This is the basic step and first analogy of any kind of ternary diagram. Ternary diagram, you can segment it into the 6 parts, that is the 1 zone, 2 zone, we move anti-clockwise, 3 zone, 4 zone, 5 zone, 5 zone, or 5th zone, or 6th zone. We can divide and demarcate the zone according to our attributes, according to our database, according to our purpose. This is the basic and foremost analogy to draw any kind of equilateral triangle to used as a ternary diagram. It's the midpoint of x-axis, it's the midpoint of y-axis, and it's the z-axis. We just connect the 3 points, midpoint of x-axis to the midpoint of y-axis, and midpoint of y-axis to midpoint of z-axis, and z-axis to x-axis. So we can, with the help of a linear straight line, we can easily connect that 3 lines. Okay, and another is, and with the connecting these 3 lines, we can get a small equilateral triangle within this big triangle. Okay, now forget about the big triangle, think about the small triangle. This is the 50% of the whole line, this point is the 50%, and this is also the 50%. So in percentage, this is the line of 50%. Okay, 50% on an average. Okay, and this is also the 50% line, and this is also the 50% line. With the help of compass or linear scale, we can take the measurement. Okay, first one is that this linear distance, this is the intersecting point, and from this intersecting point, this linear distance is exactly equal to this one and this one. Better to say, with the help of cursor, this is the 3 equal distance. Okay, and another 3 lines, this one, and this one is exactly equal. If you get the measurement with the help of compass, you put your compass in center and consider this point to this apex point, this point to this apex point, and this point to this apex point individually as a 100% line. So from that center to that point, this is the 1/3, and this line is exactly 2/3. So this is the line, that part is 1/3, this is another 1/3, this is another 1/3. Okay, so we can take the linear distance with the help of compass, and we can put the compass in center, and with the help of compass we can take the radius value, r value, from that center to that 1/3 distance. With the help of compass we can draw a small circle inside the triangle. Okay, and here come to the three important numerical value that that proposed by Ashok Mitra. Those three numerical values is 6, 11 and 16. If you sum up 6, 11 and 16, that total gross value is 33%. What is the significance of 33%? 33% is nothing but the one third of 100%. 1/3 of 100%. Okay, so 33% is the magic. So 1/3 linear distance, with the help of 1/3 linear distance, we can draw the small circle. And similarly, this 1/3 linear distance, the circle draw with the help of 1/3 linear distance from the center, is just touch the line of 50%. This is the line of 50%. This is the half distance. This is the line of 50%, and this is the line of 50%. Ashok Mitra proposed three important numericals. This is the three important numericals. We can plot these three numericals, 6, 11 and 16, according to our need, our choice, our database, our purpose and our attributes. So if you consider the 1/3 distance as a 50% distance, so we can plot 6, 11 and 16 according to our linear scale. We can, when initially I have plotted that line equilateral for equilateral triangle, this is the linear distance. The 0 to 100% is equal to 100 units. If 10 units is equal to 10 centimeters is equal to 10 units, so 0.1, 0.2, 0.3, we can plot it according to scale. According to scale, 6 will be 0.6, 11 will be 1.1 if 10 centimeter is equal to 10 unit. If we considered the scale according to, we have to consider our scale according to our basic linear distance, and we have to take the distance from center to that point, that is 33%, and we have to plot three small rings. First one is the 4.6 according to scale, second one is 1.1 according to scale, and third one is also the 1/3 distance that touches the 50% line, that is the 16%. This line, because the analogy behind this fact, this linear distance is 1/3. This is one thing. Another thing is that Ashok Mitra also mentioned that you have to plot, if according to your data you can plot, you can alter your data set, you can alter your drawing, you can plot it 6, 11 and 16 ratio, if even in 1/3 or the 2/3 ratio. Why the 2/3? Even in the 2/3 ratio, what do you mean by 2/3? If we plot it in 2/3 ratio, then we have to follow the axis, the linear distance that contain the 2/3 distance. This is the 2/3 distance. According to purpose, we can draw according to our objective. Even we can plot it even in the 2/3 length of the axis. It's a trilateral triangle. Okay, this is big one, and this is the mid of z-axis. This is the mid value of y-axis. This is the mid value of y-axis. That's why I have write down 50, 50 and 50. Just connect the mid value, we can get the small triangle. Now forget about the rest of the triangle. Think about the small equilateral triangle. With the help of compass, we can draw a small circle. with the help of the linear distance. If we think this distance solely, so this is 1/3, this is 2/3, this is another 1/3. Okay, so this is the 1/3 distance. 1/3 means the 33%. Okay, if we consider this is the 100% and it is 100%, and similarly this one is 100%, this is the intersecting or origin point, so we can get the 1/3 linear distance as a radius value, and we can draw a circle. Okay, here the drawing is not perfect. You can draw the circle perfectly. The circle touches the, this is the circle, touches the line of 50, that is mid value. So this is the circle. So we can get the three numerical according to Ashok Mitra, that is 6, 11 and 16. If we add 3, then the value will be 33. What is the magic value? What is the magic behind the number of 33? 33 is the 1/3 of the 100%. If we consider this is the 50 value containing the 50% of the triangle. If we consider it's a 100%, so from this base to apex it is 100%, apex to base is 100%, and similarly base to apex is 100%. This distance is 1/3, this is 2/3, this is the 2/3, 1/3, 1/3 and 1/3. So this is 2/3 distance, this is 1/3 distance. With the help of compass, we that is get the 1/3 linear distance. I have plot the circle that is touches the line of 50%, that is equivalent to 33% of the total length. Okay, now come to the point of 6, 11 and 16. Okay, if we consider the 6, 11 and 16, then we have to think about the scale. If this distance, this linear distance considered as 100%, 100 unit according to scale, then 100 units, we are all familiar that the ternary diagram always calculate all these things in 100 units. Then we have to plot the 100 units, that linear distance according to scale. What will be the 6 units, what will be the 11 units, what will be the 16 units. Suppose in an imaginary data 110 centimeter is equal to 100 units, so 1 unit is equal to 0.1, so 6 unit is equal to 0.6. You have to plot according to the scale the full length. This is the full length, this is the full length is equivalent to 100 units. So you can take the measurement according to the scale. Suppose it's a 0.6, and you have to plot all these things from the gravity point, origin point, and plot it and draw the circle according to very neatly according to scale, that is the 6. And suppose for 11 it is 1.1 according to scale, and you have to plot 1.1. You can get 3 small concentric ring, 1, 2 and 3. The third ring is equivalent to touches the line of 50% or half, that is equivalent. And if you add 0.6 and 1.1 and 1.6, that is 6 plus 11 plus 16, that all will be the 33%. That we can divide the 1/3 line into the 33%. This is another way. According to your data, you can plot it, and according to your own database, own attributes. And another way, the numerical according to Ashok Mitra is fixed 6, 11 and 16. You can plot according to your data 2/3 axis. Here I have plot in 1/3 axis. If you want to, if your database is quite different, then you have to plot, and you can choose the option the data linear distance, that is 2/3, and you have to divide the 2/3 according to scale 6, 11 and 16. 6 into 2/3, 11 into 2/3 and 16 into 2/3, that will be includes the 66%, and this is 33%. Okay, this is 66% and this is 33 and 66, almost 100%. So according to your database, first step is to draw the equilateral triangle and identify the midpoint, and you can draw the small equilateral triangle, and similar way you can plot the three concentric zone either on the basis of 1/3 linear distance or on the basis of 2/3 linear distance. If your data is large in range, then you can get the option of 66%, that is 2/3 into 6, 11 and 16 ratio, that is the 33 ratio, that will be 63 after doubling, and otherwise you can get the option of 33. This is the basic analogy behind the ternary diagram, which has been proposed and implemented in revised way after Ashok Mitra. But according to your database, you can choose option, you can identify the range, you can plot it according to your own attributes, own research work, and own database. In ternary diagram, these three perpendicular intersect in that point. That point plays a very vital role. This is the center point, this is the gravity point. The basic analogy of the gravity point or center point of ternary diagram is similar to the Cartesian coordinate system or polar coordinate system, just like a zero or the point of origin. In that point, there is a complete equilibrium condition. Okay, there is an equality, or there is a good association and symmetrical association among the three components of the ternary diagram. If the diversities of the diagram increases, the asymmetries of the three component increases towards the boundary of the triangle. Okay, if we move from the center, from the outside of the boundary to the outside of the triangle, then diversity increases. Therefore, it is true that the maximum equity or equilibrium condition lies within the center. According to Ashok Mitra, if the intersecting points of three component lies within the small zone of the triangle, that is there is a diversities in between 0 to 100%, sorry, 0 to 50%. This is the 50% line, this is the 50% point, and this is the 50% point. So if the intersecting points of the three component lines between that zone and this zone and this zone, rather outside of the small triangle areas, then the disparities, the association of the three components ranges between the 50 to 100%. Okay, now come to the point of concentric ring. There are three small concentric rings, small one, next one, and third one. Okay, according to your purpose, you can intersect or you can divide the ring according to their own way. Here I would like to mention another analogy that is similar to that type of demarcation. Suppose we are all familiar with the median value. Median is nothing but the middle point of the data set. Maybe we can plot same data set in percentile, decile, quintile, even in the quartile. Okay, we can segment it in 10 hubs, 4 hubs, 100 hubs, and 1000 parts according to our own way. So here the core value, core circle, the concentric circle, that is small one, the diversity is less. Here are the three components of the ternary diagram. There is a very good association and asymmetry in that three components. Then this is the second zone and this is the third zone. Okay, this percentage is 0 to 50%, and this is the and the percentage that plotted according to Ashok Mitra, that is the 6, 11 and 16 ratio. This is nothing but the 1/3, that is this length is the 1/3 of the axis. So you can plot it according to your own way. So basic question is that all the symmetry starts from intersecting point, that is the midpoint, and that asymmetry increase towards the outside of the core region. So with the help of ternary diagram, according to your own data, you can plot it and you can draw it and you can interpret it and you can divide the zone according to your database and data range. And 0 point, the origin point of the ternary diagram is the zone of symmetry in between the three components of the ternary diagram.